Welcome everybody here. If you could please take your seats and we shall begin. I'd like to welcome everyone to this side event on atmospheric monitoring of substances under multilateral environmental agreements, specifically looking at opportunities for synergistic action. Systematic observation and measurement of the Earth's atmosphere, they're fundamental to understanding its composition and the dynamics and detecting any changes and their potential impacts. In particular, the continuous monitoring of substances regulated under the Multilateral Environmental Agreements, or MEAs, is crucial to this. So this side event will underscore and look at the critical role of atmospheric monitoring in relation to substances regulated under the Montreal Protocol, the Stockholm and Minamata Conventions. We're going to be looking at the possibilities for cooperation among the existing monitoring programs and the networks of the above-mentioned treaties, identifying opportunities to build synergies across these conventions, improving access to global resources and expertise, and also looking at how we can advance a more comprehensive and efficient global monitoring framework. So without any further ado, I would like to invite the first keynote speaker to come up, which is Megumi Seki, the Executive Secretary of the Montreal Protocol Ozone Secretariat.
Thank you very much, Stephanie. Good afternoon, everyone. So atmospheric monitoring under the Vienna Convention, we have this atmospheric monitoring activities in Vienna Convention and the Montreal Protocol. So under the Vienna Convention, it has always been a top priority issue for the parties of the Vienna Convention. The focus is mainly on monitoring of the ozone molecules and ultraviolet radiation. And then in the recent years, the atmospheric monitoring of controlled substances or substances that are controlled under the Montreal Protocol has jumped to the top of the agenda of the parties of the Montreal Protocol. Now, today for the Ozone Secretariat, the focus of this event will be the atmospheric monitoring of controlled substances, and I would like to provide a little bit of a background on this issue. So in 2018, scientists found that there was an unexpected and persistent increase in global emissions of CFC-11, and that was happening from 2012 also. The global ban on CFC-11 production actually happened already in 2010. So there shouldn't have been that kind of an increase in CFC-11 in the atmosphere. So then also further studies, scientific studies, suggested that about 60% of that increase is originating in East Asia, and most of that was actually coming from Eastern China. So as a result of these findings, of course, parties were really surprised and alarmed, and they took action, decisive action very quickly, collectively and also individually. And especially China, they took immediate action to try to find where these emissions were coming from, and they managed to control that. At the same time, they embarked on building monitoring stations to be able to catch this kind of unexpected emissions. So I think they are quite successful in doing that building of monitoring stations in China, especially in the eastern coast. And I think they're coming up with several stations, maybe about 20 to 24 even, I heard. And not all of them are operational at this stage yet. So, thanks to the quick warning by the scientists and immediate action by the parties, the ozone layer did not suffer a big damage, and ozone layer recovery is back on track. This incident showed that the Montreal Protocol is working, and it's working well, and at the same time, it was a wake-up call. It highlighted the need to strengthen the global monitoring network and fill existing gaps in these monitoring stations around the world, so that we will be able to detect this kind of increased concentrations and emissions in the atmosphere, and action can be taken quickly to stop such emissions. Since then, the parties have been working towards filling the gaps in these monitoring stations for improved coverage around the world. And important decisions have been taken by the parties last year to enable this kind of work under the Montreal Protocol to start fully. Now, I would like to thank all the atmospheric monitoring experts and relevant organizations such as our long-term partner, WMO, that are working with us and supporting this work to enable parties to take informed decisions on this important matter. We have also been in touch with other monitoring networks, such as the GAO network of WMO, that's the Global Atmospheric Watch Network, Chemicals Monitoring Network of BRS and Minamata Convention, CTBTO, GEMSAIR, and so on, to explore possibilities to collaborate. Today we have the BRS Secretariat and the Minamata Convention Secretariat here to discuss their monitoring activities and visions. I'm looking forward to gaining a deeper understanding of their activities and see how we can synergize with the help of WMO. So thank you.
Thank you very much, Meg, for that overview there. And next up, it is also my great pleasure to invite Rolf Payet, the Executive Secretary of the Basel, Rotterdam and Stockholm Conventions.
Excellencies, colleagues, global air monitoring is like putting a thermometer in your tongue when you're trying to find out whether you got a fever or not. It is so vital for us to measure how effective our global conventions are. But what we see is a disproportionate network. Networks are more concentrated in the global north, and we have patches of them in the global south. So we have serious work to do there. As you know, under the Stockholm Convention, we have a global monitoring plan for persistent organic pollutants, and what we call the GMP. It provides a scientific foundation for our effectiveness evaluation of the convention under Article 16 of the convention. We have a global network of passive as well as active samplers, including stations in all regions, such as the Arctic, even Antarctica, and also remote islands. So providing us a picture of how we're doing in terms of implementation of the convention. So we have 34 POPs currently in force, 3 sets of PFAS, flame retardants, and 16 pesticides. And as you can imagine, picking those from the atmosphere can be a complex exercise if you talk to an atmospheric chemist. You need high quality equipment, you need standard samples against which to refer to it, and that is why we have such a patchiness in the monitoring stations. Good news is that we've seen drops in air concentrations of PCBs, for example, since the convention came into force. Dioxins, furans, decavidis, DDT, endosulfans, all of these chemicals continue to decline, which shows that international multilateral conventions are actually working. We've also been looking at the buildup of those chemicals in human milk. This is important because it's important that we understand how these chemicals are passed on to children, for example, where it has an impact on their development. It's also important for us to understand the impact on human health. But it shows declining levels, and that is good news. Of course, we've seen increasing levels of other chemicals, such as PFAS, and that's why the Conference of the Parties a few years ago decided to implement measures for the ultimate phase-out of PFAS, which is a group of chemicals. I don't have time to go into those acronyms today, but if you want more information, I'm quite happy to provide you with those information. Now, before I end, we also have to show that there is a link to climate change as well, because a lot of the emissions from unmanaged landfills is methane, and methane is one of the biggest emitters of pressures for climate change and greenhouse gas. And their remote sensing information has been used to detect flares from landfills, especially large unmanaged landfills from around the world. And the contribution is quite significant. We'd like to thank our collaboration with the other MEAs, Montreal Protocol, Minamata Convention, and partners in the World Meteorological Organization as well. I must also give a shout out to the universities that will collaborate around the world, and also some cities that actually maintain some of these global monitoring systems. So as mentioned before, there are significant challenges, and we need to talk about those challenges. The North-South divide in terms of monitoring capacity, the lack of this specialized equipment that can be used to detect small amounts, small quantities of these chemicals in the atmosphere, and of course, tracing the deposition, degradation, or accumulation of these chemicals in the background environment, such as in the ice, such as in glaciers, such as in the soil, and then how they mobilize and enter into our food systems, our human systems, and of course, into wildlife and other components of the environment. So I'll stop here. Just wanted to highlight the importance of having global monitoring systems, because they do and continue to support the measuring of the effectiveness of our conventions. Thank you.
Thank you very much. Next up to speak, we originally had Monika Staniewicz from the Minamata Convention on Mercury, but she's unfortunately not been able to make it. So Brenda Kukuk has very kindly offered to step in and provide her remarks on her behalf. Thank you.
Thank you very much. As Stephanie has mentioned, Monika Stankiewicz, our Executive Secretary, has sent along her regrets, but wishes us a productive session today. So the Minamata Convention is one of the newer multilateral environmental agreements, which was only entered into force in 2017, so 8 years ago. So we are new to this game under the atmospheric monitoring under our convention itself, but it's clear that atmospheric science is actually what has been studied on mercury for years and actually provided the scientific evidence to actually negotiate the treaty in the first place. So the objective of our convention is to protect human health and the environment from anthropogenic emissions and releases of mercury. And Article 22 of the Convention sets out a provision to evaluate its effectiveness. And COP5, along the way, 2 years ago, agreed to a set of 36 indicators for us to assess progress against. So the framing is there. And at our COP7 in 2027, the COP will be evaluating the effectiveness of the convention for the first time. And this will be on the basis of a report that will be developed by our effectiveness evaluation group. So this report will ultimately answer the question, to what extent are existing measures under the Convention meeting the objective of protecting human health and the environment from mercury? And this question, of course, may seem small, but it's actually a really big question to unpack. The monitoring of mercury in the atmosphere is of primary importance in answering the question, and our open-ended scientific group has collected mercury monitoring data from many monitoring programs, including from data from the WMO's Global Atmospheric Watch. The monitoring data largely comes from developed countries, as Rolf has referred to, and capacity building for mercury monitoring is much needed in developing country parties. So for this, we are very much welcome. There's a new GEF program on global chemicals monitoring, which started and supports monitoring of mercury monitoring in addition to POPs, and we're very excited for this to contribute to the global data set. Overall, Article 22 in Minamata is very similar to the Stockholm Convention, and although our parties have set up different modalities and approaches for us to approach the effectiveness evaluation, we still have a lot to learn from each other and from our experiences and having a similar request, but also from other sister chemical conventions like the Montreal Protocol. And very importantly, from the scientific community around the world that's been studying mercury for years. So we look forward to a fruitful discussion today, and we look forward to new opportunities for innovation, for learning and growth together as we embark on our journey to finalize our effectiveness evaluation for 2027. So thank you.
Thank you, Brenda, for stepping in at the last minute. As you will have heard from these three keynote speeches, there's a lot to be done under atmospheric monitoring, and it's a big job in order to make sure that the atmosphere is, stays in good health, and that we can also monitor that the parties to these various conventions are also adhering to their obligations. But more on atmospheric monitoring. I will now will come up with our presenters, which I'd like to take the opportunity to introduce you to now. So first up, you will have Sofia Milona. She's the Senior Environmental Affairs Officer from the Montreal Protocol Ozone Secretariat, followed by Marilyn Beau, who is the Head of Legal and Policy Unit at the Basel, Rotterdam, and Stockholm Conventions. Unfortunately, our third presenter, Isaku Toda, who is the Senior Program Management Officer from the Minamata Convention on Mercury, couldn't be here in person, but he is sharing his presentation via a pre-recorded video link, which we'll be able to share with you. And then to round it all up, we will have Paolo Lai, who's the Chief Atmospheric Environmental Research Officer at the World Meteorological Organization, who will kind of round up the whole event. Time permitting, we hope, we will have an opportunity for a short Q&A session if we don't run over time. Thank you very much, Sophia, and apologies for that. It seems that the font, when it was picked up at this end, was being corrupted. So you have not been getting the full picture, which is kind of ironic because we are talking about atmospheric monitoring and how we don't have the full picture. So hopefully that gives you an indication of what all these conventions are up against. Next, I'd like to invite up Marilyn Beau, who is from the Basel, Rotterdam, and Stockholm Conventions, for her presentation.
Thank you very much, Stephanie. Good afternoon, everyone. It's my pleasure today to briefly present how the Stockholm Convention monitors persistent organic pollutants. And so I do have as well a presentation that I wanted to show you. But so during this presentation, we will indeed show how the data that is generated under the Stockholm Convention on POPs monitoring support global chemicals governance as well as effectiveness evaluation. And the presentation will also highlight opportunities to collaborate with monitoring under other MEAs but also with scientific bodies like the World Meteorological Organization. I think I will need to wait for the presentation, which is very illustrative, so I think we are missing, if we don't see it, missing something. Okay, well, for the sake of time, so as you might know, the Stockholm Convention controls persistent organic pollutants. Persistent organic pollutants, or POPs, persist in the environment. They show also other characteristics. They bioaccumulate in living organisms. They can travel long distances. They cause also adverse effects on human health and the environment. Because they move across borders, global action is essential to address POPs. Here we go, the slides are coming. Thank you so much. So, this slide shows the current coverage of the chemicals under the Stockholm Convention. So initially, when the convention entered into force in 2004, so already 21 years ago, it has 12 POPs listed under it, which were known as the Dirty Dozen. Most of the Dirty Dozens were pesticides at the time, so you can see on the slide they are underlined. But through the Article 8 of the Convention and the scientific work of the POPs Review Committee, the Conference of the Parties listed an additional 25 POPs since then. So today, the Convention lists 37 chemicals or groups of chemicals. These include 15 pesticides, 18 industrial chemicals, and 7 unintentionally produced POPs groups. As mentioned by Mr. Payet during his opening remarks, some of the industrial chemicals are PFAS. So we have 4 groups of PFAS that are listed under the Stockholm Convention, including PFOS and PFOA. So they are not individual chemicals, they are groups of chemicals. For example, if we look at the group of PFAS, the 4 groups of PFAS that are listed under the Stockholm Convention, in total it amounts to 870 compounds related to PFAS. Of course, this only represents only a fraction of the thousands of PFAS substances currently in use. An additional set of unintentionally produced POPs, namely brominated dioxins and mixed brominated chlorinated dioxins. This group of UPOPs, as we call them, is currently under review by the POPs Review Committee. So it's currently being assessed whether it meets the POPs criteria as defined under the Convention. So the Convention establishes a comprehensive framework for controlling POPs, mainly through 4 articles. There is Article 3, which requires parties to prohibit or restrict the production and use of listed POPs, as well as their import and export, except for the environmentally sound management of POPs waste. Then we have Article 4, which allows for time-limited specific exemptions to enable parties to phase out and substitute POPs. Article 5 requires parties to reduce and, where feasible, eliminate unintentionally releases of POPs by promoting best available techniques and best available practices. And finally, Article 6 obliges parties to identify, manage, and dispose POPs stockpiles and POPs wastes in an environmentally sound manner in line with the Basel Convention. So to evaluate the effectiveness of the Convention in protecting human health and the environment, Article 16 of the Convention establishes an effective evaluation mechanism. The evaluation of the effectiveness of the Convention is conducted every 6 years, and the next evaluation will take place in 2029. Under the same article, Article 16, the global monitoring plan for POPs, also known as the GMP, was established to provide comparable long-term monitoring data. The effectiveness evaluation of the Convention draws on three main information sources, as shown on the screen. Information deriving from Article 15, which is information from the national reporting. Article 16, which is POPs monitoring data from the GMP. And finally, information deriving from Article 17, which is information related to compliance. As you know, the Stockholm compliance mechanism was established recently in 2023, but it's currently operational and in full-fledged mode, so it will be able to provide information for the next effectiveness evaluation under the Convention. So, the latest evaluation, effectiveness evaluation was conducted in 2023 on the basis of the GMP3 report, which is the report that is generated by the Global Monitoring Plan, which provides key monitoring data. The global report, which is considered for the effectiveness evaluation, is based on regional monitoring reports prepared by regional organization groups. All regional and global reports on monitoring are available on the Convention website. You also find monitoring data from all the regions through the GMP data warehouse, which is hosted by Risotox, which is a Stockholm Convention Regional Center located in Czechia. So UNEP Chemicals and Health Branch, so UNEP supports the GMP implementation as well as capacity building in regions. UNEP supported previous GMP through various GEF projects covering 2 periods of time from 2008 to 2012, and the latest project cycle was 2016 to 2023. So from the data that was generated through the two rounds of projects, UNEP developed a GMP dashboard that shared widely the data from those projects, as well as other information that is very important on laboratory capacities. There will be now a new GEF project on GMP, which is called the Global Chemicals Monitoring Program, also GCMP, which will cover the period from 2026 to 2030. And this new program would, it's a bit different from the previous rounds of projects. This upcoming program will integrate POPs, but as well as mercury monitoring across the 5 regions. So we can see here there is also already an effort to work collaboratively across MEAs. So the Global Chemical Monitoring Program supports both Stockholm and Minamata, which we heard today contributes to the effectiveness evaluation of both conventions. So this program is expected to enhance collaboration among MEAs, but also collaboration among scientific partners, including through shared approaches, joint capacity building, and coordinated monitoring efforts. So, air is one of the core media of the Global Monitoring Plan. So the slide you see on the screen shows you the GMP air monitoring sites worldwide throughout the different cycles of the GMP. So it's all the sites that serve to monitor POPs in the air. Air samples are collected through passive sampling as well as active sampling. Passive sampling uses simple, low-maintenance devices that absorb chemicals from the air over large weeks or months, providing long-term average concentrations. Active sampling uses powered pumps to draw air through filters or subbord materials, allowing precise and short-term measurements. So it's two different methodologies for the air sampling. So on that slide, you can see results from the GMP3 report that was finalized in 2023. So for pesticides, for all pesticides actually, so including DDT, endosulfan, and HCCH, you can notice downward trends for those. While for PBDEs, dioxins, and furans, some sites showed stable or increasing trends. So this could be a sign that there is continued emissions from those POPs. Overall, these findings from African monitoring sites suggest progress in reducing environmental levels of several POPs under the convention. So, as noted also before, it's a good sign. There seems overall it's a downward trend regarding POPs air emissions in the air. But another medium that is used under the global monitoring plan is human tissues. And we wanted also to present that to you. So human tissue, including breast milk, is another core medium. So the Human Milk Survey, so this is through this program that is conducted in collaboration between UNEP and UFAO. This is through this Human Milk Survey that we are able to retrieve data on human milk monitoring. So this slide shows you the results from the human milk biomonitoring conducted over the period 2000 to 2019, so almost 20 years of coverage. So the slide shows us that there are decreasing levels of key POPs in many regions. So this decline is extremely important because it indicates reduced human exposure, especially for infants and mothers. The third medium that is used under the global monitoring plan is water. So this medium is used for water-soluble substances like PFAS. So trends in levels of PFAS listed under the Stockholm Convention help identify, of course, ongoing emissions and assess also the effectiveness of regulatory actions. However, PFAS monitoring sites are still very limited. And it's not yet possible to identify clear trends regarding the increase or decrease. But efforts are continued to improve the observance of those levels and trends over time. Now, I also would like to highlight collaborative efforts because I think that was the focus of today's side event. So, a few points here. So collaboration among chemical MEAs, in our view, can strengthen monitoring through close communication and the exchange of sharing of information and expertise. So the side event of today, I think, is a very good example in that regard. Joint efforts, such as using shared sampling sites, can produce shared snapshots of environmental conditions as well as the status of hazardous chemicals. The UNEP-GEF Global Chemical Monitoring Program is a practical example where the Stockholm and the Minamata Conventions collaborate on monitoring for effectiveness evaluation, as well as build capacities in countries. Cooperation with scientific organizations, including the World Meteorological Organization, further enhances data quality and comparability. While technical differences between treaties must be acknowledged, practical alignment still brings important benefits for cooperation and strengthen global monitoring. So in conclusion, strengthening monitoring allows us to evaluate progress, also identify emerging risks, and support science-based policy under chemicals and waste conventions, whilst enhancing cooperation among MEAs and scientific partners. Thank you.
Thank you very much, Marilyn. Next presentation is by Aisaku Toda. He's the Senior Program Management Officer at the Minamata Convention on Mercury, as mentioned previously. Unfortunately, he's not able to be here, but we do have a pre-recorded version of his presentation. If I could ask the technicians to now play that, please.
My name is Aisaku Toda, the Secretariat of the Minamata Convention on Mercury. I really wanted to participate in this event, but I could not travel to Nairobi this time. Instead, I am delivering a recorded presentation on the atmospheric monitoring of mercury. Minamata Convention addresses a single metal element, mercury. It is a relatively young convention adopted in 2013 and entered into force in 2017. Mercury, especially its organic form, metal mercury, is very persistent, bioaccumulative, and toxic. The convention is named after a city in Japan where severe metal mercury poisoning happened in 1950s and 60s. The convention controls the whole life cycle of mercury. Its supply from mercury mining, trade, use in products and processes, emission, releases, waste disposal, and the management of contaminated sites. Monitoring and measurement of mercury is important for the implementation of the Convention. Article 19 of the Convention provides for the cooperation of parties in research, development, and monitoring. Mercury is emitted and released to air and water, deposited on land and water bodies, methylated to more toxic metal mercury, accumulates in fish and other animal species, and consumed by humans. Therefore, mercury monitoring includes air, both ambient and emission, water, biotic media, such as fish and marine mammals, and humans. Article 22 says that the function of the parties, the decision-making body of the Convention, is to evaluate the effectiveness of the Convention using monitoring data. This article is very similar to the article of the Stockholm Convention. We have heard from Marilyn that 3 rounds of effectiveness evaluation have been conducted under the Stockholm Convention. Under the Minamata Convention, the first effectiveness evaluation is being conducted. COP4 in 2022 started the first effectiveness evaluation process, which will be concluded at COP7 in 2027. COP4 established the open-ended scientific group to put together a scientific report based on mercury monitoring and taking into account the estimation of mercury emissions and releases and the modeling of movement of mercury in the environment. The group consists of experts nominated by parties, 1 for each party, and supported by other experts in the roster nominated by parties and observers. There are subgroups looking at different environmental media, human biomonitoring, emissions, and integrated analysis. For this presentation, I am focusing on air monitoring. Much of the slides today are taken from the OESG co-chair and the air group lead, Dr. Sandy Steffen of Environment Camp. The OESG has collected mercury monitoring data from parties and literature and looking into a number of data analysis questions. Firstly, the group is looking into the current levels of mercury in the environment, as well as emissions. The current level of mercury in the global atmosphere is somewhere between 1 and 2 nanogram per cubic meters. This level is quite low compared with conventional air pollutants such as sulfur dioxide and nitrogen oxides. This is not the level at which direct respiratory exposure becomes a problem. As I explained earlier, the problem of global mercury pollution is with the exception of poisoning from mercury vapor in hotspots such as the gold processing sites, mainly through the bioaccumulation in fish and other food items. The second and third questions are about temporal and spatial trend, whether we can say anything about increasing or decreasing trend of mercury levels or any geographical patterns. OESG is further looking into higher level questions. The fourth one is whether the observed trend in the environmental level of mercury is attributable to changes in emissions and releases, and further to the measures taken under the Minamata Convention. It seems that the currently available monitoring data are not sufficient even to conclude on the global temporal trend, so this question is largely for the future. The fifth question is about exposure and adverse impact. The last one is about the understanding of the processes used using environmental transport and exposure models. These questions are also largely for the future. Now I'm going into the atmospheric monitoring. Mercury is measured in different ways. Mercury is detecting using different techniques, but for air monitoring, atomic absorption spectrometry is usually used. Since the mercury levels in the ambient air is not high enough, mercury is usually trapped on cold or other surfaces through active sampling and analyzed. The mercury analysis is done manually or automatically. There are continuous monitoring instruments out there that can measure mercury levels every 5 minutes or so. However, as I will explain later, most of the mercury monitoring data using active sampling are from developed countries. European Monitoring and Evaluation Program, Arctic Monitoring and Assessment Program, monitoring programs in the US, Canada, China, Japan, and so on. There are passive monitoring techniques that are less expensive. Also, wet detection is measured by collecting precipitation. This map shows the monitoring points collected by the OESG. As you see, most of the active monitoring sites and wet deposition monitoring sites are located in the northern hemisphere. Active sampling data from southern hemisphere is very useful, including those from the Global Atmospheric Watch site in Cape Point, South Africa. Continuous monitoring and sampling from tower is conducted at that point. Also, as Maridine mentioned, the Global Environmental Facility, GEF, started the Global Chemical Monitoring Program this year. This program is an evolution from the Global POPs Monitoring Program, where passive monitoring of mercury was added, using common monitoring sites. The data from this program cannot be used for the current first effectiveness evaluation, but we look forward to using the monitoring data for the next effectiveness evaluation cycle. The OESG is currently finalizing the data analysis report. We hope to post the draft report on the website early next year. This slide shows part of the data from the different geographical locations. The OESG is also looking into the estimation of mercury emissions releases. EDGAR database is an atmospheric emission estimation by the European Union's Joint Research Centre, also covering greenhouse gases and other air pollutants. Mercury is emitted to air from various sources. The largest source of mercury emission is artisanal small-scale gold mining. Mercury is used for about small-scale gold miners to amalgamate to extract gold. This practice not only pollutes the global environment, but also causes direct health effects to the miners and pollutes the rivers and soils. The second largest source is coal combustion, since mercury is contained in coal and other fossil fuels. Mercury is also emitted from metal smelting and cement production. The estimation of mercury emission from ASGM is a big challenge. EDGAR estimates mercury emission from energy consumption and industrial data using emission factors estimated from technological assumptions. However, ASGM sector is usually an informal sector, and the data on gold production for the mercury use are in most cases missing. Under the convention, parties have to establish national action plans to reduce or eliminate the use of mercury in ASGM, and these plans are to include the baseline estimates of mercury use. However, due to the uncertainty of the information of ASGM, it is very difficult to compare the estimation by different parties. The OESC is working to connect the monitoring data and the emission estimation using mechanistic models. The multi-compartment mercury modeling and analysis project is a joint project under the Minamata Convention and the UNEP Air Convention's Hemispheric Transport Task Force, led by Ashu Dasto of Environment Canada. In this program, as input, EDGAR emission inventory was used, and the Chinese official emission estimation was also used to compare the result. Natural emissions and re-emission of mercury deposited on land and water are also important for the model. The estimation using the mechanistic models is compared with the mercury observation data, elemental mercury, mercury oxide, and wet deposition. This final slide was presented at the side event at the Minamata Convention COP6 held last month. Models seem to capture spatial variation of mercury observation, but many regions lack observation coverage. This is where the science stands in terms of global monitoring and modeling of mercury. As Minamata Convention is a relatively young convention, we would like to learn from the experiences of other conventions. Mercury monitoring is simpler than other complicated organic substances. It has been measured for a long time as part of pollution monitoring. However, conventional pollution monitoring focuses on detecting mercury levels that are harmful to human health, and we need to monitor lower levels of mercury concentration for the global purposes. Cooperation between different conventions is emerging, including the GEF, Global Chemicals Monitoring Program, and mercury monitoring at the GAW site. We look forward to further collaboration. Thank you very much.
Thank you for that presentation, Isaku, and I'd like to now call on Paolo Lai, who unfortunately comes last, and you're going to have to be very quick. He's the head of atmospheric environmental research under the Global Atmospheric Watch at the World Meteorological Organization.
Thank you. So I will be fast. I was asked to integrate a bit the three presentations and explain why we have no choice but to collocate what we do and our monitoring system. So if I can have the first slide of my presentation. So I'm Paolo Lai from the WMO and running the Global Atmospheric Watch program. We are global, so stations a bit everywhere, but I will share that the fact that we have, no, that's not me, the fact that we need information from many places in the world, and we are facing the fact that many regions in the south do not have enough observations. So I don't know if I can have my first slide, and I wanted to take you with this first slide to Bolivia. This is the station that we have, Chacaltaya Station in Bolivia, 5,000 to 300 meters in the Andes, 30 kilometers away from La Paz, very far from any pollution sources. And this is the inside of the station. And you see that you have inside the station plenty of instruments. This is one of our, we have more or less 400 stations running a bit everywhere in the world. And this is one of our 35 flagship stations. You have about 55 variables measured there, including ozone, including some aerosol, greenhouse gases, and mercury. And I would like to take this an example of what we do with the mercury and the fact, and if you can go to the next slide, the fact that, oh yeah, I have that. If you take the variability of the different the variables that we are measuring there. And you have an example there on the left of the general variability of mercury, total mercury, and CO and black carbon. And from correlation of all these variables, because some of them are indicators of biomass burning, some others are indicators of mining, some others are indicators of long-range transport from different regions, from the ocean. Some of them are indicators of what we get when air from La Paz is lifted up to the station. Taking all this information together using models, then you can say something that if you would have only mercury measured at the station, you couldn't tell. And I have a little sketch of the mercury cycle there. What can we say? We can say that, for example, when you have the biomass burning, then you have emission of mercury. When you have the mining, obviously, is also mercury emitters. But when you have volcanic eruptions, you also have more mercury. When you have the deposition and the rain over the Amazon, then you see the mercury going down. So this is all mercury cycle that you cannot tell if you had only mercury in your station. So this is what we have. Its collocation is not new. And when you go to the guidance documents from the Montreal Protocol, from the POP Convention, from the Minamata Convention, it is there. The recommendation is clear. You have to collocate. And on the graph, what you see is the first up, the graph on the upper side is some mercury sites from what we just heard, Minamata Convention. On the other side, the other figure is the POP Convention, and highlighted in white or red are the stations that are actually collocated with the Global Atmospheric Watch and what we do for ozone. So you see that we have a bit of a match, but we still have lots of mismatch in the system. And to illustrate, this is easy to see on the map, but to illustrate one of the issues that we have to face, I took a very simple and silly example, and you take the code, the station codes in the three associated with the three conventions, and you see that, and you compare that to our WIGOS, so our information system codes that we have for all meteorological stations in the world, from the World Meteorological Organization, and then you see that a station that is called something, a code with a code in the one convention is called with another name in the WMO system or in another convention. And can you imagine, from a user perspective, the difficulty to reconcile all that? You also have stations that have the same code, but they are not the same place at all. So what is collocation is already an issue. And this is a very simple example, but we have also some more problematic examples of collocation. Collocation is not only about a physical place where you do the measurements together, it's also after you measured where you send the information. And each of the conventions so far have their own information system. So when you do an assessment, you rely only on the information that you get from your own information system. And this is not the best way to proceed. For the reason that I explained before, if you want to have the full picture. So we have to go from a system that is going parallel like that to a system that is a bit more integrated, yes, which is an information system that would be like that. And that's very easy to say on a PPT slide, but much more difficult to implement. And there are lots of discussion in this UNEP 7 on digitalization, on the way things are organized. You have the weather booth over there in the main center that is discussing that. We know it's extremely complicated. You need same standards. It's not only the codes of the station, it's also vocabulary. It's plenty of issues that are extremely difficult to put in place, to implement. But I would say that we have no choice. We have no choice but to do that. And perhaps the fact that AI is now a tool for integrating might be a game changer. So to conclude, and this is my last slide, is about the pros and cons of collocating. I think obviously you had to put some issues that where collocating is not the perfect solution, and scientists They are often asking for a very specific place, a blue tower from some scientists and a green tower from others. But I think, again, we have no choice because we don't have the financial capacity to have networks all over the world operated in a different manner, and we really have to integrate. We have to integrate for cost reasons, for the data quality, for the capacity building, because the same technicians, the same engineers are the same people at the stations, for reliability, but also for the data management, and this is the most important issue that I would like to raise. That. With that, I'm finished, and I thank you very much for the attention.
Thank you, Paolo, for being so very quick. Thank you very much to all of the presenters and Isaku, who's actually following this through the live stream. You've certainly helped improve our understanding of the monitoring already being undertaken by the conventions and also the WMO, where there are gaps and where there are potential opportunities for future collaboration, co-location, co-cost sharing of facilities, as well as other practical options for enhancing monitoring capacities. And with that, I think we need to close for the next side event. And thank you very much for your attention and thank you for coming.
Using Shopify POS has really created that connected tissue from in-store and online. It's really seamless and easy.